Vamos conseguir fazer.
Thank you very much. All right. So I was saying we have the optical fiber and that draw up. We have N1 and N2, the refractive indices of the core and the cladding respectively. And I was saying after our voice message, after the transducers, after the whole laba, until we get to our light source, we have two types, mainly two types of light sources that mentioned lasers, optical fibers. What are those? Unmute. The other one.
Laser. Laser light.
The other one.
LED.
LED. My light source is edu. So what happens? Signal rago rashika. Orosangana ni light source. Iro light source ready. Oro vala launch come optical fiber. Kutirichi transport. Kutirichi transmit. Whatever it is. Dola is ready rupinda optical fiber. What happens? Ripinda optical fiber. It is totally internally reflected. Oro arafamba kuskarashika ku receive on the other end. But chi chinopa kuti rive totally internally reflected. What is needed? But no launch a light redu, light launch kwarese is. What is needed? Kuti light redu rikapinda Recite refracted robudo. Question that needs a response. What is needed? Katombo Tower at the video before. What is needed? Anyone to respond to
that? Correct acceptance angle.
Correct acceptance angle. Acceptance angle. What defines the acceptance angle? Right. What defines the acceptance angle? It all begins with that critical angle. So it begins with that critical angle. We have my questions here. Attention, this equation, the critical angle. We have another equation, Snell's law. Sin theta 1 is equal to sin theta 2. If you combine these two from interfaces, detail more on the other videos. Now I'm just resuming summary of where you need to see what is very special exam. If you combine those two equations, from boundaries. For example, here we have a boundary. A boundary between A on this side or any medium kurukuba light source. Mostly A, it can be A, it can be water. Never know. And we have the core. So we have an air core boundary or interface. If you study that boundary using this Snell's law and the critical angle, if you study that boundary, it leads you to the equation where you have the angle of acceptance. Sin theta 0, n1 minus n2 over n squared, which is also called the numerical aperture. Definition, you need to know what the numerical aperture is. This is our angle of acceptance here, angle of acceptance. Definition, what is the numerical aperture?
It is the angle of acceptance.
The numerical aperture is the light accepting efficiency of the optical fiber. the angle of acceptance is theta 0. Theta 0 is not equal to NA. Sine theta 0 is the numerical aperture. The angle of acceptance is something else. It's not equal to the numerical aperture. The numerical aperture is the light accepting efficiency of the optical fiber, the ability to capture light. It's like the more light you capture, I think it will vary. What is the opposite of inversely? Variation is the inverse energy. Can't find the word. We have inverse variation. The other one is direct. It will vary directly. Thank you very much. It will vary directly with the quality of your signal. Optical fiber add up here at this point. When we launch light track or launch the signal you get on the receiver here will be very poor. The light launch is that light accepting efficiency. Are you collecting light track here? To one maximum SNR, if I may say, at the receiver. So the light accepting efficiency is something important from optical fiber sped up. And we have definition, and we also have a formula. NA is equals to N1 squared minus N2 squared over this area, over N squared. Most of the times when this N is A, it means N is equals to 1. You need to know my refractive index of very which we are definitely going to use. We have air, we have also water. You need to know this, these two. N is equals to 1.33. N1, refractive index of the core. N2, refractive index of the cladding. N can differ depending on the material ripper boundary raco with the core. It can be air, it can be water, it can be wood, I don't know. But I know for definitely these two, you see them, air and water. All right, after the light accepting efficiency, we go to, all right, the angle of acceptance. If your angle here, theta, is greater than, this is my core, this is my axis, this is my cone. We have this. I'll call this the cone of, what is that? Cone of acceptance. What is the name of that cone? One of my videos, there is a name for that. Someone help me. Let's call that the cone of acceptance. I'm not sure it's called the cone of acceptance though. It's sort of a cone. What does it represent? It has the accepting angle, theta 0 to theta 0 for the cone of acceptance. This is the angle at which you are supposed to launch your light. If you launch light, for example, from this point, angle is cone. What will happen here? Light track chapinda, yes, but it will get refracted. So if theta is greater than theta 0, where theta 0 is the angle of acceptance, light is refracted. Light refract, it has huge consequences. You have loss of data. So you need to launch your light to this angle of acceptance, theta 0. If theta is less than theta 0, green, then we have light in here. Light is going to be pedu, then it is refracted. Basics. We have TI R if theta is less than 30. Examples. Questions you'll be getting. Questions you'll be getting, the simple ones. You are given N1. You're given N2. Find the numerical aperture. Simple mathematics, you plug in 1.45, 1.44. Here, it depends on the boundary with the core. What medium is on the boundary with the core? If it is air, this N is equals to 1. If it is water, that N is equal to 1.33. 3-4 marks. Pass exam. All right. These are the type of questions you'll be getting. And obviously, my definitions. What is the refractive index? What is the numerical aperture? I mean, calculate the angle of acceptance. Calculate theta 0. You will be asked to calculate theta 0. What is theta 0? If you have a numerical aperture, it is equal to sine theta 0. Simple mathematics, ladies and gentlemen. All right. Ray theory of light. Everything that I summarize here to this point, if I can say, it is called the ray theory of light. We also have what we call the wave theory of light. This one, it deals mainly with rays, total internal reflection. How are they moving? How are the rays moving in an optical fiber? Ray theory, it deals with mainly the total internal reflection. Contact wave theory, here we'll talk about modes. With modes, we introduced single mode optical fiber, multi-mode optical fiber. Right. Question so far. Nope. Havana. Thank you very much. All right. To be used in calculations, you need to know this, what we call the refractive index difference. Refractive index difference. You need to know this. It's just a formula. N1 squared minus N2 squared over 2 N1 squared. In some of my questions you will be getting, you may be given only N1. Find the numerical aperture. You're given the refractive index 1%. Find the numerical aperture. How do you deal with this? How do you find N2? Simple mathematics. Here you have N1, you have your N2 here, you have your refractive index difference here. Simple mathematics. So I just had to introduce this, the refractive index difference. You'll be seeing it a lot in my test and obviously the exam. With that, simple mathematics can lead you to this. The numerical aperture will be equal to N1 the square root of T2 delta. All right. For a high acceptance angle, the numerical aperture needs to be big, which means N2 should be small, N1 is equals to blah, 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 blah. All right. Right. Formula numerical aperture. N1 squared minus N2 squared. What do we need? Could this light accepting efficiency even big? What do we need? I explained that in the video. If you want your light accepting efficiency with respect to my refractive indices, if you want it to be big, what does that mean for the relationship indices? Anybody? Machine one there,
N1 must be very, very big than N2.
N1 must be very, very big. Thank you very much. Yes, N1 must be very, very big. But it has a limit though. N1 optical fibers, it cannot be very, very big. Or one N1 like 2 optical fibers. It is very small. Probably 1.5 in less. So what that means, to not delay the other one. N2 should be very, very small. This one should be small so that our light accepting efficiency is very big. And the minimum value my refractive index is obviously 1. That is the minimum value. So N2 when it is least, when it is equal to 1, what does that mean? It means our light accepting efficiency, let us say, it increases. If that increases, obviously, what does that mean when N2 is equal to 1? The tarot refractive index can be equal to 1. It's not a way. Refractive index is equal to 1 dash.
A.
The A. So what does that mean to our cladding? Right now, cladding panap again N2 is equals to 1.44. Take it now to the light accepting efficiency doing increase. At 1.44, N2 is equals to 1. What does that mean? It means we no longer have a cladding here. So logic tells me kuti inini pa optical fiber yangu ndodo tiriwe accepting efficiency is very big. Acceptance angle is very big. Acceptance angle is very big. It means obviously signal to noise ratio yangu no increase. Signal rangu rinopinda rine power yakati O. It means obviously and skuda cladding. Because nikangoisa cladding light accepting efficiency yangu decrease. Then the question, why do we require cladding? Can I decrease a light accepting efficiency? Why we need cladding? But now I'm explaining data unit. Momberu mendongo rupindura. Pindura ona I'm explaining data unit. So about that way. I repeat Momberu. Momberu, admit yourself. Anyone else and squeezes on the tower is at Zogoro. Panya cladding. Why we need cladding? Zogoro to I'm waiting. I'll wait. Anyone answer Wapanya cladding up. Create up a traditional cladding. Then the question, why do we need the cladding then? Why you cladding? Nobody. Man's what by them through tower. But this is a all right.
It same see.
On got to dim gab.
Mamuchiti zvoni kuti tite maximum cone acceptance yecone N2 edu anofanira ari 1 ndo minimum yachona ndika. Then kana N edu ari 1 zvoreva kuti refractive inonzi medium ine refractive index 1 inenge iri A. So means kuti tiite the maximum acceptance yecone, the pane cladding paper pafanike pane A, since A iriyo ine index iri 1.
Thank you very much. Zvikareva kuti tikabvisa cladding now, sei maoptical fibers edu ane cladding izvezvi. Theoretically, we don't need cladding. But maoptical fibers edu izvezvi ane cladding. Why? Pana kambo, in fact, ndakaubvunza mubvunzo wemuvidhio ndikazopindura later on. Pana akasvika kuanswer, why do we need cladding? Nope. All right. Question 1 assignment. Why we need cladding? All right. Those are 5 marks. Why we need cladding? Just a minute. Why we need cladding? Assignment 1. All right. We have my types of rays. We have skew rays. You need to know that. We have what we call skew rays. We have what we call meridional rays. From our optical fiber, and draw and this is my core. This is my cladding. I'm gonna draw a skew rays. They don't cross the axis. Definition. Or let me just say this is my core. Don't care about the cladding. This is my core. And axis recorded in the area. And as my skew rays are, when they move, they do not cross the axis. So I don't move. Actually, I saw core. Something like this. That's how they move. Kamaisa and so very difficult to explain. But for meridional rays, they cross the axis. Do I told you? Don't get describe axis here. I'm going to cross actually. But these ones, they don't do this crossing front by axis up. How do I draw it? As when I get this cross sectional view, I draw a guy. I am going to put an up. I do my meridional rays. I don't put any up. But axis up. But for these ones, they don't pass through that axis. You need to know the difference between these two rays. I've never encountered another skew rays. Hopefully, someone researches what I want to skew rays with one day. I've dealt with meridional though. Right. You need to know the difference between these two. Definitely, you see one of these in class or my exam. Wave theory of light. So I said the ray theory of light, we mainly focus on the movement of light using total internal reflection. Ray theory, it focuses mainly on total internal reflection. Now we have the wave theory. What is the wave theory? All right, light, it is composed of electric and magnetic fields. Electromagnetism. Here we are. Light is composed of electromagnetic and electrical and magnetic fields, E and H. Light takes different paths depending on the angle of incidence. Right. Because of this, we have what we call modes. I'm not going to go deep how we go from electric and magnetic fields to my modes now. You can deal with my videos. It will show you that. Because of these fields, it can lead us to having multiple modes of propagation. Propagation. In between this, we have Maxwell's equation. Maxwell bangani? Four equations. You need to know those. Maxwell's 4 equations. Banana Maxwell's 4 equations. And I know all one is Maxwell. Anybody respond to that? At easy. Quara. Maxwell equations
No say
magate electromagnetism here. Anyone knows some Maxwell's equations?
makangano mzizi.
Makangano wase the question is right, Maxwell's equations, you need to know this. Maxwell's equations, one and those even the rate of change of is it electrical? No, the vector sum of my electrical is equal to 0. Right. I think this is Gauss's law. Do one and do 0. Right. Pane Faraday futhi papa. Faraday's law, if I'm not mistaken.
The Amber's law.
Paneji ape.
Amber's law.
In dindo dise for kanga rosinis. Mimi no. Because pane wandra Sarah. I think you don't draw Gaussy. You need to know just my equations. You need to know 4 Maxwell's equations. If we have time, I think I can take you how we come from these two using 4 Maxwell's equations. This is another course, and I'm not willing to engage in that. But I'm hoping in one of the videos, I see about 10 minutes. It's worth knowing up using 4 Maxwell's equations. How do you get there? If you have time, engage. How do you get there? Right. So tikashika modes of propagation, do particularly these two. Single mode, cells, single mode, and multi-mode optical fiber. Definition: single mode optical fiber. Layman terms. Single mode, multi-mode optical fiber. How does it define the roles in it? Oh, for your Andy.
A single mode, you know, only a single ray of light.
Yeah.
Only a single mode of. Multi-mode.
Obviously, multi-mode didn't mount. That is the difference.
Yeah.
That is the difference. You need to know this. I don't announce my modes. Not necessarily my rays, but modes. What causes good multiple modes is because of interaction in my electronic and my magnetic fields. Pakatika modes, we have multi-mode optical fiber carrying multiple modes. In this one, only carries a single mode. Right. Speed of light in a medium, we dealt with that. Videos 2 and 3 done. Number 4. What else? Questions so far? V number. Questions Nope. All right, you need to know what is a single mode optical fiber, what is a multiple mode optical fibers. Best way to answer that question if you're asked, put draws and data. That is best way. Engineers, we are not very good with the ways. I think I've said that before. And I don't require you to near my paragraph. That's why I want to for my exam. Because I don't near my paragraph, I don't need that. Every question and up on that. Kunyora 6-7 lines for a response. It means also Dora. And can I make exam and rungo check. It is what it is. All right, I just need to change that and store not using a mode. Kalain get ready kako. That was what engineer was what using a mode. All right, that our is a V number. Next, we have what we call the V number. This is a number which can be used to determine if an optical fiber is single mode or multiple mode. Definition: the V number describes the relationship between the numerical aperture and the radius of the core. The V number describes the relationship between the numerical aperture and the radius of the core. 2 pi over lambda naught A NA. Where NA, this is my numerical aperture. You need to know this formula. A, what is A? My video is A. One mangasika ba video number ani. Diana Jena don't respond. Chief Guara, my videos makaita mangani. Makaita mangani.
Another video number 40.
Yeah, first I'm famba nayo. I'm busy my videos. Yes, and now Zamaru after 4 weeks. In class test, I'm gonna do it this Friday. Samaru famba in a pace very quick. All right. Panaga put a video number 4. Ngwerume. Washka video number here. Or what video number she?
7.
Number 7. Okay. Murufa no famba ne pace I got to all. All right. I think V number is around video number 4 or 5. So I think I'm going to end here. Kuti mfano chova my videos. We have another session midweek. But let me just finish up. V number, a relationship between numerical aperture and the radius of the core. There we have the definition, where A is the radius, lambda 0, wavelength of light. This is my V number. It can help us to show the optical fiber is single mode or is it multiple mode. What helps us do that? If V is less than 2.408, this means your optical fiber is single mode. If your V is less than that value, it means optical fiber is single mode. So my typical questions you'll be getting relating to that V number. You know, gonna tangle N1, N2. What your N1, what your N2. Find the numerical aperture of that optical fiber. It's operating at a given wavelength. Its radius is equals to find the V number. This is you are given. You're given is operating in this wavelength. It has a radius of this. You're given N1, N2, find the NA, find the V number. What type of V number determine if it is single mode or multi-mode? How do you then determine that? If V is less than 2.408, then it means it is single mode. These are the type of things I'm jumping down on. All right. You need also to know, I think I explained around the same time I explained what in number nyaya ku increase this diameter. This is my core, this is my cladding. This is the diameter core ish. 2A. A and the radius. A I'm hoping is the radius. So this is my diameter 2A. What happens if 2A decreases? 2A require or decrease to this extent. 2A I'm going to decrease the issue. You have a somewhere up. What happens? I want a video. What happens if we decrease the core of the radius of the core? What is the difference between the single mode and the multi-mode optical fibers in terms of the core, the radius of the core? Which one is larger? Which one is smaller? I respond down.
Huh?
It becomes single mode. Thank you very much. It becomes a single mode. If we decrease the radius of the core, it becomes a single mode. That is theoretically. That's why my multi-mode optical fibers ukachaga radius yacho is bigger than, much bigger. Is bigger than the radius of the single mode optical fiber. This radius is smaller than this one. So that is one thing you need to take note. Can I my videos? Go through my videos. And I think we are done. Less than 1 minute. We have another session, possibly Friday. We'll see. Catch up with my videos. I'm going to end this session and begin another one with an assignment. Stop. Assignment and